Let's talk about trapezoids. Trapezoids are kind of the odd duck of the quadrilateral world because unlike parallelograms, or rectangles, rhombi, and squares, trapezoids only have one pair of parallel sides. We call those sides the bases, the top and the bottom. So then we call the non-parallel sides, we call those legs. So the big defining characteristic of trapezoids is that it has one pair of parallel bases. Now, that has a few implications for the angles involved in a trapezoid. So if we think of, and if we highlight these bases that are parallel, and then we highlight this leg, suddenly it looks an awful lot like the picture that we're familiar with for with two parallel lines and a transversal that creates all kinds of congruent angles and supplementary angles. Specifically, we have these angles here that are same side interior, and thus they are supplementary. So they're going to add to 180 degrees. Now, the same thing is going to happen on this side. We have two parallel lines going through a different transversal. So that's also going to create some supplementary angles as well. So those guys will add up to 180 as well. But it's important to realize that because these legs hit at different slants, this set of angles is going to be completely different than this set of angles in a typical run-of-the-mill trapezoid. So just be careful that you don't conflate things as equal or supplementary that are not, because those legs are hitting at a different slant. So consecutive angles are supplementary to an extent. They have to be along a leg rather than, in this picture, side to side along a base. So let's see how that plays out in some problems that you might see in your geometry course. Here is a trapezoid that has some angles that are marked, and we're asked to find angle C and angle A. Well, again, we're going to be working on kind of two different wavelengths here. On the one hand, these angles over here will have their own relationship, and then these angles over here will have their own relationship. And because they are consecutive angles along the leg, they are supplementary. So let's see how that problem solving works. Over here on the left, well, we know that 42 plus angle A is going to add up to 180 degrees. Which means that A is going to be 180 minus 42, which is 138 degrees for angle A. Over here, we also have two angles over here in the green that will add up to 180 degrees, but of course they have variables and we'll be doing some algebra, but the setup is fundamentally going to still be the same. We'll take the two angles, 12x minus 3, and add it to the other angle, 9x minus 6, and set that sum equal to 180 degrees. And then we're just going to, 21x. We're just going to do a little simplification here. Minus 9 equals 189. After we add the 9 over, it's going to equal 189. So, yes, we got 21x equals 189. X is going to equal 9. Now, we weren't asked to find x, we were asked to find angle C. So, our expression for angle C is just 9 times that x value, which is 9, minus 6. That's going to give us 75 degrees. So, again, essentially the same strategy. We're going to set those two consecutive angles along the leg to sum up to 180 degrees. Now, let's see what happens when we throw in a diagonal like AC here. We're asked to find two angles. We're asked to find angle DAC, so that's right there. And we're asked to find angle BAC, which is going to be right there. Well, one thing that we've got going for us here is these two parallel bases and a transversal that goes between them. So this particular situation is going to set up alternate interior angles. So this 54 and this green angle up here is also going to be 54 degrees because they are alternate interior. Now, we have a couple of different ways to find angle A, or angle DAC rather. The way I'm going to show you is that we know that angle A up there, all of angle A, and angle D down here will have to add up to 180 degrees because they are consecutive angles along a leg. So let's go ahead and set that up. We'll have this 64 down there at angle D, adding the 54 that we just found, and the unknown angle DAC, which we're going to call X. They need to add up to 180. That's going to give us 118 plus X equals 180. And then subtracting, we're going to get X equals 62 degrees. So that's 62. Now, the other way we could have done this problem is to see this triangle here and see that we have two angles, 64 and 54, defined, and we are missing the unknown. So actually, it would turn out to be the exact same math. 64 plus 54 plus X equals 180 degrees. So interesting that we have two different ways to solve the same problem, and they actually use the exact same equation. So you'll notice here so far in our discussion of trapezoids, we haven't really talked about side lengths, and that's because since we only have one pair of parallel sides in a trapezoid, there's really nothing that's governing the length of those sides. The one base can be much longer than the other and create a much more dramatic angle with the legs. The legs can hit at different angles, as we know. So really, there hasn't been a whole lot to talk about with lengths associated with trapezoids until now, because the isosceles trapezoid brings in the additional factor of congruent legs. In an isosceles trapezoid, the legs are congruent. Now, the bases, of course, are still parallel, so I'll mark those differently. But the legs are congruent. Now, what that does for us is that it also creates a situation where angles along a base, we would call those base angles, they are congruent. And these two would also be congruent. Now, angles along a leg are still supplementary. So we have a lot more symmetry all of a sudden with an isosceles trapezoid. The other thing that goes on is these diagonals, which I'll throw in a couple of diagonals here. Oh, that's not a very good drawing, but you get the idea. There we go. We have diagonals, and the diagonals are congruent. The diagonals are congruent as well. Diags congruent. Now, this is not a situation like we have in parallelograms where the intersection of those diagonals creates a situation where the diagonals are bisected. They are not bisected. A diagonal is not cut in half, but what we do have is that these two halves, parts, are congruent, and these two parts are congruent. So it's a little bit of a different breakdown compared to a parallelogram or a rectangle, rhombus, square, any of those things. So let's see how that might play out in a problem-solving situation. Here we have an isosceles trapezoid. It's marked because those legs are marked congruent. Those legs have expressions containing the variable y, and then we have a note down here at the bottom. We have a note down here at the bottom that the diagonals have these values containing the letter x, and we're asked to find all of these things right here. Well, let's start off by solving for x. Now, we know that TA looks like a full diagonal, and RP looks like a full diagonal. So we know in an isosceles trapezoid, they have to be congruent. They have to be equal measures with each other. So let's set that up. One diagonal equals the other diagonal. Let's see, that's going to wind up being 7x, and then we're going to add 37, so that's, what, 56? And then that gives us x equals 8, so we're going to write 8 up there with our x. I'm going to skip solving for y because I want to finish with the diagonals first. So now RP, here we go, right in there. Well, we just need to plug in that x value for that. 12 times 8 minus 37. Looks like that is going to give us 59. So RP equals 59. Now we have the stuff with the legs. So 10y and 4y plus 18. Well, they also have to be congruent. 10y equals 4y plus 18. 6y equals 18. Y is going to be 3. So y is 3, and then TP, well, 10 times 3 is just going to be 30. So there you have it, some good information there about trapezoids and isosceles trapezoids and how you might see their characteristics reflected in different problems that you might see in your class. I'd encourage you to please give me a subscription here, subscribe to the channel here, Common Sense Math Help, and you'll have access to all of my videos. And please drop a comment with another video that you'd like to see, another topic that you'd like to see covered. Thank you. You're working hard. Keep it up. Take care.